This is another quadratic formula problem, and again, if you tried to do an easy diamond with this, you would not be able to find two numbers that multiply to 9 and add to -4. So that's the big tip-off. So I'm going to write down the quadratic formula up here in the right corner. And this is something that you're going to use so many times that you probably will have no choice but to have it memorized. So the first thing you want to do with this problem is identify A, B, and C. So A is 1, B is -4, and C is 9. So I'm going to write these numbers in where the formula says. Now what I have here is -4. That's actually going to turn into +4. But for right now I'm going to leave it how it is. -4 squared minus 4 times A times C. And then it's over 2 times A. Now the next thing we want to do, like I said, this is going to turn into +4, is I want to figure out what is this stuff that's under the radical. So when I put this in my calculator, I'm not putting the radical in, I'm only putting in the numbers. So I'm going to switch to my calculator here, and I'm going to type in -4. Oops, I need parentheses. So in parentheses, -4 squared minus 4 times A, which was 1, times C, which was 9. So no radical, I'm just putting everything under the radical in, and it gives me -20. So now I'm going to go back to my problem, and I'm putting in a -20. Now this problem is a little more difficult than the previous one because now I can do a factor tree. And that negative is also going to turn into that imaginary number I that's going to come out of the radical. But let's deal with the factor tree first. So I'm going to break down 20 into 2 times 10. 2 you cannot break down anymore, so I'm going to circle it. And then 10 is 2 times 5, which both get circles because you can't go any farther. I have a pair of 2's. So what's going to happen here is I have 4 plus or minus. I can take out a 2. I can also take out an I, and that's because of the negative under the radical. And then left over is this 5 right here. So that goes under the radical, and then everything is still over 2. Now we have one last thing to deal with. This 4, the 2, and this 2, those are all my outside numbers. They're all divisible by 2. So what I can do now is I can reduce this like one big fraction. So I'm going to divide the 4 by 2, the 2 by 2, and the 2 by 2. And in order to reduce, you have to be able to reduce all 3 of those numbers. The number under the radical doesn't count. That's protected by the radical. All right, 4 divided by 2 is 2. 2 divided by 2 is 1, so I don't even have to write it. I can just put I and then square root 5. And then 2 divided by 2 in the denominator is also 1. So when you have 1 in the denominator, you don't have to write it. So this would be my final answer.